Hi friends, this is a introduction to Temporal using the new TypeScript SDK, basically assuming that you know almost nothing about Temporal apart from you heard about it from somebody, that's why you're watching this video, and you think it could be cool. I assure you it is, and I'll hopefully guide you through all the basics that you need to know to get started and to figure out whether or not you want to use this thing. So the plan of attack for today is that we will have a few steps. We'll talk a little bit about what is temporal. I won't give you too much of the sales pitch, I promise. Then we'll talk a little bit about the APIs that you should know. I'll motivate the example with a Next.js application, just so you can see it integrated into a real app. Then I'll actually do some live coding to get you started and actually show you the step-by-step of how to get up and running so that you can do it yourself if you so choose. And then we'll be done. So hopefully you can strap in, and hopefully this will be a really good basis for understanding the rest of Temporal and where it fits in your overall stack. Okay, what is Temporal? Temporal is the open source microservice orchestration platform for writing long-running workflows as code. So I don't actually have to emphasize microservice, but that's just the industry accepted term. You can use that however you wish. Serverless functions also fit in there. I don't care the size of the service, just that you use multiple systems. Whenever you make a third-party API call, whenever you call to another team, anything like that. And long running, meaning that you have a unit of business logic that spans across multiple systems. So one example I like to bring up is how would you write Uber? The reason I like to bring this up is because Temporal's founders actually came from Uber, which is where this system was created and open source and picked up by a lot of other companies. And when I say write Uber, I don't mean the app, I don't mean the front end, I mean the back end, the really business critical stuff of, hey, I need to search for a place to go, I need a price for it, I need to be matched with a driver, I need to be picked up, dropped off, rating, tipping, payment, email. Imagine that each of these stages in the process take place over minutes, maybe hours, and they're crossing systems designed and maintained by multiple teams. Some of them will have downtime, some of them will need retries, some of them will need branching. How do you manage all of this complexity in your application as someone who is writing some of these systems? Once you handle the happy path, then think about the unhappy path or the additional features that Uber supports, like Uber Pool, managing what happens when drivers are lost, canceling, changing the route, getting refunds, anything that happens along the way that may interrupt the normal flow of things. The typical way you might naively coordinate between systems is you might go from system A to system B to system C. The problems come when, let's say, system B has an outage, or system C takes a super long time, way longer than normal because it's hanging and it's not really down, it's just not responsive. So what you start needing to do is you need to introduce timers and for retries, and you need to store that retries so that if your system goes down, you can pick it back up again and remember that you still need to do a retry. And for unresponsive systems, you also need to make sure that they time out. So if they take too long, longer than expected, you should time them out and fail them proactively and retry again on a sibling system. So nuances like that. Once you start having all these needs, you start realizing that there's a lot of common infrastructure and code that is basically a production requirement across all your systems, and you want to start centralizing them. And that difference is called choreography versus orchestration. So a lot of what we do is provide you a microservice orchestration platform that is that single runtime, so you can focus on business logic, just like every other developer tool. And hopefully that is the promise that we deliver to you. The way that we do this is we let you write workflows and to act on the outside world with activities, and Temporal Server is that central runtime that coordinates all these workflows and activities. Temporal itself has been adopted as an open source framework by a lot of companies, including Box, Descript, Snapchat, Coinbase, Datadog, Checker, HashiCorp, and DoorDash, and they all use it for different things because it's such a general purpose tool for such a cross-cutting concern. So for example, Box uses it for file transfer, whereas Coinbase uses it for financial transactions. But Descript might use it for a data pipeline. Checker might use it for background human in the loop processes. HashiCorp uses it for infrastructure provisioning. DoorDash might use it for deliveries. Datadog and Snapchat might use it for infrastructure needs. Netflix also uses it for CI/CD, and you can check our YouTube for some examples of how they do all these long-running processes in the context of their business needs. So the elevator pitch overall is that the most valuable mission-critical workload in any software company is long-running and ties together multiple services. Because this work relies on unreliable networks and systems, you need a reliability layer on top of that. So you want to standardize timeouts and retries, and to make every team more productive, you want to offer reliability on Rails to every team. Because this work is so important, you must never drop any work. So everything must be persistent, and you must log all progress so you can have a immutable log of what happened when. Because this work is so complex, you also want to model it. You want to easily model any dynamic asynchronous logic and reuse, test, version, and migrate it, which is why we start emphasizing workflows as code, because the most flexible way to model business logic is with general purpose languages and not JSON or YAML or boxes and arrows or directed acyclic graphs. Overall, the core opinions, though, I can personally reduce it and make some comparison to React in that we want you to use a framework to organize your code. So React asks you to organize your front end into components and then provides a renderer. In the same way, Temporal asks you to organize your systems into workflows and provides an orchestrator between them. It wants you to have correctness, so React uses a functional approach, and Temporal uses event sourcing to ensure correctness of your sequence of execution. And in the programming model, React emphasizes just JavaScript and not some templating language, and Temporal also has a similar philosophy. So I just want to make that comparison just because many of you are probably familiar with React. Okay, so we're going through the API walkthrough section of this talk now, and we'll present to you a few APIs and then follow that up by practical applications. So I want to present to you what a workflow is and looks like. A workflow is just a function, so it takes some arguments and it returns some values. And that's the workflow definition. And a workflow client can call it externally and say like, okay, I'm going to start a workflow, and that's going to kick off that workflow. It can seem a bit like a background job runner, but I'll show you why it's not really. It's a kind of like a superset of background job runners. So the first API that we're going to talk through is the workflow API, and it literally is just a function, and it takes some arguments and returns some results just like any other function, but it does have some special rules and limitations to it. It has to be deterministic, so there's no non-deterministic activity like calling out to math.random or reading from the file system or pinging an API. That has to be done in activities, which I'm going to show you next. And then you can call workflows in workflow clients, and this can be any part embedded inside of your application. Let's say your serverless function or API route handler, and say where you can say, I'm going to kick off a workflow with these arguments, and that's going to take that argument and process a result. This one in particular is going to say hello world. Okay, so what if you want to do something interesting? You have to act on the outside world. Then we go to activities, which are executed in the regular Node.js environment and can have access to all the things that you normally do in Node.js. So here I'm going to charge a credit card. Here I'm going to call an API. That's an activity. Also, activity is also a function. And an activity can be called inside of a workflow. There's some setup here that I'm omitting, but just understand that workflows can coordinate multiple activities, and you just call them like you would call a function, and that would call the outside world. The last part of the system that I have to show you is the worker. So remember, you had the client to kick off a workflow. That basically logs that job inside of the internal task queue in Temporal. You still need some machine to pick off that from that task queue and start processing that work, and that's what the worker does. A worker is a process or a machine that you run that executes your workflows and activities according to what is said or logged on Temporal server. So overall, if you tie together all the systems, it kind of looks like this. Your app is here, where it has a Temporal client embedded to it. It calls out using gRPC to Temporal server or the Temporal cluster. Temporal's clusters job is to persist all state changes, and then also assign work to workers that are listening on certain task queues. And the workers hold all these workflows and activities to execute, whether or not it's calculate the next state transition for workflows or to do something in the outside world for activities. And that's the rough order operation as well, because there's usually some separation of responsibilities between application developers and the central temporal platform. So that's a very basic app structure, but it's a lot of setup to do Hello World. Why does this matter at all? It's basically whenever you start doing anything to do with time, and that's where Temporal comes into the picture. So for example, the part of the activity setup that I included was how you define timeouts and retries. So now everything is declarative instead of you having to provision infrastructure and to manually code it up. Now you can actually fine tune all these knobs that Temporal gives you. So for example, if I want to have an activity that charges an API, I can define timeouts and I'm going to define the retry policy. We'll play a little bit with what this is, but basically whenever you call your activity, if that activity fails for the first time, it's going to back off and retry according to the policy that's specified here. And that's a very useful thing because now you have a lot more reliability sort of built into your system by default. And once you have that timer, so just remember that this centralized timer and persistence structure. Once you have that timer and you're coordinating these interactions between systems and you're able to track the success and failure and the time elapsed and be able to time them out or retry them as you see fit, it then becomes very easy to actually introduce artificial timers into your workflows itself. So that's kind of what we have here. So if I wanted to do an installment plan workflow, for example, I can give an amount, and I can charge a card, and I can actually sleep for 30 days and then charge to a credit card again. That sleep is a durable timer, meaning it's not just held in memory, it actually is held inside of that database. So if the system goes down, if my worker goes down, if my server goes down, any part of the system goes down, I just bring it back up again and it picks up right where it left off. There's some magic behind that, but it's actually not too bad. Basically, we track the entire execution history and replay it until the point of where it left off and then continue again. So that's essentially what it does. And I think this timer actually introduces very interesting programming models, which I'm going to give some examples of later on. But once you can sleep for a certain amount of time, you can actually do an infinite loop, and that is also totally fine because each of these loops, you're not tying up a process. It basically hydrates and persists every single time. So here, for example, if I want to do a subscription workflow, I can just say I can charge that card and then sleep until the next month and charge the card again and sleep until the next month and charge the card again until such time as until I cancel the whole workflow, which I can also do externally. So I actually don't need anything else to implement a subscription model until apart from just this code, which is pretty brilliant. Of course, as something is long running, you actually want to probably update something as send in data so that it can react to the external world. So we have this concept called signal, and signal is just a way to send in data to a running workflow. And so here I have an update signal, and that lets you send in a new amount to charge. So if, let's say, the person has upgraded their plan, they can send in a higher amount, and that will take effect at the next cycle of billing. So those are the main APIs that I wanted to introduce to you. That was a world tour. And finally, there is some tooling that Temporal provides out of the box where you can audit everything that happens, the sequence of events, as well as trace through and understand and debug. So I think that's the main sequence that we're going to be guiding you through today. Okay, that was a whirlwind API walkthrough. Don't worry, we'll get to see them again when we go through the live coding section of this tutorial. But I want to show you quickly a relatable and small example where all of this starts clicking into the picture. So the example that I like is the one-click buy, because our CEO actually worked on this back when he was at Amazon. And the story of the one-click buy actually was being told by Joe Spolsky, which I can link you to that talk. But essentially, Jeff Bezos wanted a one-click buy experience, but they struggled to make it one click because they wanted their minds were set around asynchronous user experience, which is check something into a shopping cart, and then the user goes to the shopping cart and then checks it out. The big unlock was to actually just check it right through the order process, but set a timer for them to change their minds. And then you raise the timer against human interaction. If the humans come in and cancel their purchase, then you have to cancel that timer and not let the order go through. But if the user does not cancel their purchase, then the timer, when it completes, it has to let that order go through. So a lot of minute interactions like this can actually be coordinated using timers versus signals. And those are all the concepts that I introduced to you earlier. So I have an example of this running, and it's a Next.js application. And it's easy enough to code the front end, and you can click the Buy Now button, and it's going to start having that pop up with a 5-second timeout. And once that 5 seconds elapse, it's going to go back and say that it's purchased. I can also click buy and have that timer come up and click cancel. And that's the main interaction. That's actually pretty trivial to code on the front end, but what we need to do is code this on the back end and have it persist, right? Because I could just click buy now and then close my browser and go away. So that state needs to be tracked in the back end, that timer needs to be set, and it needs to be set durably because there's money involved. So all of that is inside of my code example here. I'm going to show you a little bit. It's probably going to be overwhelming, but if you're familiar with Next.js, this will at least be familiar to you that it's been designed specifically with a real use case in mind. So here's the example of the app that I just wrote. So I have my components and my page, and it's fetching an API. The main part of the application is really the API routes, which are the serverless functions. And here I have some clients that have been set up. So first I can start a purchase, and that start by function actually just creates a client, and then it says it starts a workflow. It kicks off a purchase. That workflow is defined inside of a temporal folder. So I'm treating the Next.js folder as a monorepo. The temporal folder has a workflows file, and this file defines what happens when that purchase kicks off. So I can set up a listener for a cancellation. I can set up a listener for a query, which is it just checks the status of something. And then I can race the cancellation against a workflow condition of a 5-second timeout. If that happens, I can cancel that purchase. If it doesn't happen, I can check it out. So that's the rough process of the workflow that we went through. And finally, I should probably also cover the signals that we send in. So here in my cancel API route, I can send in a signal saying that this purchase was canceled, or I can say that I can query the state of the purchase and check what the purchase state is. So those are all the components that we can talk about in our buy example, and we'll be able to build this from scratch after this part of the coding tutorial. Okay, so we're now in the live code section of this tutorial where we'll actually go step by step through the code from an empty folder. There are some prerequisites to this tutorial. So if you want to know what they are and set them up accordingly, go to temporal.io/node. That's a shortcut to our docs. And it's going to tell you that there are some prerequisites to the node version. You have to install node.jip and to install temporal server using Docker Compose, which is what we recommend. I have all the containers running here accordingly, and that's the preset that you should start off with. So I start off in this empty folder, and I'm going to run npx at temporal.io, temporal.io create/latest. Okay, that should initialize a folder, and that will have the basic project structure that we're going to go through today. So let's explore this project structure. It basically is a standard TypeScript project. The only thing in the package.json that you should really know about is that there is a temporal IO dependency. And right now we're at version 11. It may be different by the time you see this. But inside of our node modules, that actually brings in a bunch of other libraries that is sort of like a bundle package. So it actually imports temporal IO activity, client, worker, and workflow inside of your node modules, and those are the main ones that you're going to interact with. The other parts, which are inside the source folder, has activities, worker, workflows, and execute workflow, which contains the client. So the activity just has a simple function, just like we saw in our intro. The workflow also has a simple function, just like we saw in our intro, that calls the activity. The activity is set up with our timeouts and retries, as mentioned here. The worker registers the activities and workflows as promised. And then in the client can kick off a workflow just by calling workflow.execute. Okay, so that's the rough structure. Let's actually run this thing so we can actually see how that works. So I'm going to say I'm going to cd into that folder. So and I'm going to say npm run workflow. And so now that's actually going to go through and execute this little script here, which is meant to simulate like an API route handling or serverless function handling, whatever you want to call this function in. And it says handle.execute temporal. Let's see that inside of the UI. So when you spun up the Docker Compose, you actually spun up a web UI container as well, and that's located on localhost 8088. And so this is the function that we just ran. It has an input temporal, and that matches the argument temporal that we just sent in here. But it's still running, so it's actually kicked off that workflow execution, but it's not completing. It's not actually printing out the hello world that we expected. And that's mainly because there is no worker yet. So temporal by default registers and logs all incoming messages. And this incoming message came from the execute workflow file. And now we need a worker to process this file. So let's actually bring that up. So I'm going to have another window over here, and that's going to be running the worker. So here, let's bring up the worker code. Worker, again, registers activities and workflows. The worker bundles the workflows via Webpack, and then it runs the activities inside of Node.js, the standard Node.js environment. The reason we use Webpack to bundle it is so that we can run it inside of a deterministic environment, which is a VM from Node. Okay, and finally, probably the last thing to note is that they're both listening on the tutorial task queue. So something I forgot to show you is that this workflow that we kicked off is actually waiting on a task queue, and that means that we can run several of these, and it all just pile up in the task queue. But there are no pollers. There's nothing listening to that task queue to take that job off the queue and to keep executing it. So right now, let's kick up some workers, and that will start listening to that task queue. So I'm going to kick off a worker. So I think that's npm run start for us. I'm in the wrong folder. And that is npm run start for us. And now that worker is going to come in. And immediately once that worker comes in, I want you to see that the workflow execution completes. Because now there's something to execute that file, and that code has been specially written to block until that workflow is executed. If I said handle.start over here, then that would not wait for the execution and would just continue going. So let's see what happens with our worker. So the worker is now pulling that task queue that we mentioned. All right, you can see it over here. And now if we go back, we can see that history-wise, it's actually gone through the whole sequence of events and actually taken the input and computed an output, and that's a hello world that we saw in the console over here. So a fairly complex process, but all of these are persisted and fault tolerant, and which is very cool. So now that the worker is running, I can actually run a couple more workflows, and it should execute basically right away. Now that the worker is running, I'm going to kick off another workflow. And you can see that because the worker is running, it doesn't pause or stall at all. It just goes in, does the calculation once it's picked up at the queue, and then it's computed. So that is in a nutshell what the hello world example is with Temporal, letting you run workers and then execute workflows and execute that logic of workflows and activities in sequence. So, okay, that's very interesting, but also it's just saying hello world. It's a really over-engineered hello world. So we need to do something that's more interesting than that. And let's explore the domain of activities, which hopefully will start doing some interesting things related to Temporal that you couldn't do on your own. So let's go into the activities folder, and this time we're going to do something crazy to it. We're going to make it always fail, just to simulate some unreliable activity that whether or not the system is down or the code is wrong or the network is unreliable, we're just going to say that it always throws a new error. All right, so I don't care what the error message is, but this activity will never complete because it always throws. So now I want to make it obvious that this activity will retry by default. So I haven't changed any of the other code. What I'm going to do is I'm going to kill this worker because the worker's job is to register activities. It was still running that old activity. I had to kill it and then rerun it to pick up the new activity that I just changed. And so this new activity is always going to fail. Okay, so now the relevant part is that this workflow is running that activity, but the activity now has been rigged so that it always failed. So I just want to show you what happens when we run something like that and how Temporal responds. So I'm going to kick off that workflow, and we're going to see it try to execute again. And now something different is going to happen, where if I look at the status of that workflow, we can actually see something interesting, that it's responding by retrying a failing activity. So we can see that there's actually a pending activity, and it's in attempt number 5 of retrying it. And that's basically because the activity is just set up to always fail. So it's going to keep retrying until it backs off. So here I can see that it's going to retry again in 2 seconds. So 2 seconds have probably passed. And if I refresh it, now it's on attempt number 7 because I took that long to talk. So there is an exponential backoff process, and you can configure that inside of here by saying whatever you like. For example, backoff coefficient of 1, that would be a linear process, and 2 would be doubling it every time. Okay, so that's an interesting behavior, but something I also like is that if let's just simulate my worker crashing. So over here, the thing that's processing this retries is crashing. It's supposed to process that code. It's crashing. I could also crash Temporal server as well, but that would take a bit more time. But I just want to demonstrate to you that every single part of this is persisted. So when I bring it back up again, it just picks up where it left off. And as I see it right now, it's still in attempt number 8 of retrying. Probably 16 seconds have passed. So 6, 5, 4, 3, 2, 1, and then we'll have attempt number 9 of retries. Okay, fantastic. All right, so I've proven that that can work. And that's what happens with timeouts and retries. It basically ensures a reliability layer for activities, and you can write your workflows as though your activities are a bit more fault tolerant than they would normally otherwise be, and that's a really nice convenience. Let's actually hotfix that activity to pass now and see this. This process has been waiting for the activity to come through. So what I have to do is kill the worker again to pick up the new workflow, and I'm going to start the activity. I'm going to start the worker. So now that the activity has been fixed, this process should retry properly and pass. So it's still waiting to retry though. So let's just see how long it's got left on the retry. It's still got 46 seconds. Let's count down the clock. There. So that has just completed, and now there's no more retry attempts because we fixed that work activity, we killed the worker, brought it back up again, and now it's running a new code that passes, so that workflow client call is now completing. So that's how that activity and timeout semantic works across the worker and the client. So now let's actually do some interesting stuff with the outside world with Axios. I'm going to install Axios and ping an API. So npm install Axios. And now I can go inside my activity and paste some pre-written code I have that calls an API. All right, so now this should just call an API, and I just wanted to show you how to call APIs just because that's a fairly common thing to want to do. And you should only import anything to do with the outside world inside of activities and not workflows, because workflows are deterministic. So let's go ahead and run a workflow and see that in action. So again, that workflow client is going to kick off a workflow, and that's going to go to Temporal server, and then that's going to be processed by a Temporal worker, and that's going to come back to Temporal server and then come back to the client. So that's the API call that's been done here. So just to be super clear on the mental model that I've been talking about, it's literally we're simulating with execute workflow that little script that kicks off that workflow, goes into Temporal cluster, that gets picked off of a queue by Temporal worker, that processes the activity or the workflow, sends it back, and then it communicates back and forth with timers and retries and timeouts and all that stuff. And only once it's done, then it calls back if I wanted it to. So that's kind of the system architecture that we're going through here. Okay, so we completed the activity section of this walkthrough, and now we're only talking about workflow APIs. So this will be an interesting section because I no longer need to talk about activities. I would assume that you know the basics of what activities do, but workflows have their own APIs, which also make things very interesting. They're basically asynchronous primitives that you can use to write some pretty interesting business logic. So I've refactored the workflow function to only have that sleep API. We're going to console log sleep, and then we're going to sleep for 10 seconds, and then we're going to wake up again, and then the workflow will complete. So let's run this code like we're used to. I'm going to say npm run start over here to kick off the worker. The worker registers that workflow and just starts waiting for work to come in. Once that worker is up and running, I can do something like npm run workflow and kick off that workflow. I didn't actually have to have the worker running, as you remember from the hello world example. So I can do this out of order. It doesn't matter. Everything's persisted anyway. We do not lose data. So right now it's receiving that workflow and it's sleeping. So we logged out the word sleeping over here. And now it's waiting 10 seconds, and then it's logging out waiting, and now it's printing hello, and then that workflow is executing. So that shows the timer in action. But I wanted to show you what happens when, again, if you run npm run workflow and it kicks off that workflow, now it's running at sleep, but I crashed the worker intentionally. Let's see what happens here with the workflow that we kicked off. So here the worker is still running even after 10 seconds have elapsed. Let's look at the history. So it's started that workflow execution, and then it started that timer at 11:46, and 10 seconds later it resolved, and now it's scheduled the next task of the next part of the workflow that's over here, but it hasn't been executed here because there is no worker to process that. So let's go ahead and spin that worker back up again. You see on the left, this workflow is still waiting for that to complete execution. So now I'm going to spin out the worker again and have that workflow history go through. So if I refresh it over here, oh, yep, that workflow history should go, and that. So that's the workflow.sleep demo. You can actually use this API to do some interesting things. For example, have an updatable sleep, or you have to race it against the timer, for example, for setting reminder emails and stuff like that. But that's only probably useful in the context of the last two features that we're going to go over, which is condition and signals and queries. So I've gone ahead and refactored the workflow to use signals, queries, and the condition timer. So here I have an increment signal, and that's literally a message that comes into a workflow while it's still running. A query that's called get count, and that's a signal that someone else can send to get data from the running workflow. And then I can set listeners inside of my workflow that pulls in and closes over internal states. So here I have a counter that's I, and every time every time the increment signal is called, I am going to do I++, and the set listener just returns the value of I. The get count query just returns the value of I. And then finally, I'm going to block the completion of this workflow using workflow.condition. And for this to evaluate to true, I has to reach 3. Once that I reaches 3, it's going to say, congrats, you just hit 3, and then that workflow is done. So the last part of this refactor is that I need to have a script for sending signals and making queries. So I'm going to fast forward through that process. Okay, I've done 3 things here. So first of all, I've modified the core execute workflow code a little bit. Now I've specified a consistent workflow ID that I'm going to be reusing throughout. And then I've changed handle.execute to handle.start so that now this execute workflow code, when I run it, it's just going to go right through and not wait for the result to finish, because that's going to go right into the workflow where it could potentially be waiting for a very long time. So then I cloned that code into a signal workflow script and a query workflow script. So the signal workflow script is basically just that exact same thing. It refers to that workflow ID, so it picks up where that workflow left off. And now I'm going to send that signal of increment into my workflow. That workflow has a listener set up to receive that increment signal, and that's going to increment that internal state. And then it's going to complete and say signal done. Same thing for the query, except for the query, you actually get back a result by design, and we're going to log that result out. So now let's put all this to the test. I'm going to bring the workflows code up again, and I'm going to bring our trusty workers and script runner here. So I'm going to restart the workflow. I'm going to restart the worker, and this worker now has knowledge of the new workflow that I've just written. And then we can do some fun stuff. So now I'm going to kick off that workflow. Remember, this only starts an execution, but then it just doesn't wait. It's just going to terminate immediately. And I'm going to show you inside of the UI. So here's that workflow that we just kicked off. I have the custom workflow ID here that I specified, otherwise it's auto-generated. And now it's just waiting. It's just waiting for new signals to come in. It's just kind of chilling. There's nothing else to do. Temporal is perfectly happy just running millions of these concurrently, waiting for interaction to come on in. So now let's kick off a signal. So now let's kick off a signal. This will be the first increment signal coming in and being processed by the workflow. You can see that as that signal comes in, this console logs out increment 0 as expected, and it's going to increment that by 1. You can see over here in the history, if I refresh it, that it's going to have a workflow execution signaled event, and it's logging that it happened. So we're going to do a couple more times. So I'm going to signal the workflow again. It's going to increment to 1. I think I should actually go ahead and query this before it actually hits 3. So I'm going to say query workflow, and I just want to show you that query working as well. So remember, this workflow is just a super long running process. I'm interacting with it by sending in data. I'm getting data out of it. So the status is 2 now because I've done ++ here. Okay, so we're in the home stretch. The state of I is 2, and now I just need to send in one more signal for that condition to complete. And it's supposed to log out. You just hit 3 over in my worker. You just hit 3 over in my worker. And now that workflow is done. So let's look at the whole journey of that workflow. So it was a long running workflow that was essentially blocking for arbitrary human interaction. So I started it at 11:57 and it went up till 12:04. And I sent in signals at points in time. I sent in a query as well. It's not logged here because it doesn't affect the state. And then when I sent in my last signal, it basically competed right away and said it was done. So this is really useful for making sure that a bunch of conditions are true and waiting for external data to come on in and to be queried while it's running. So let's take a review of what we've done today. We covered what is temporal, an API walkthrough, a one-click buy example that hopefully is small and relatable. And then we walked through every single part of that code to actually make it go live so that you can follow along at home. That, of course, is just scratching the surface. There are a bunch more features that I could not show you, including some very important security and production features, like being able to test your workflows that help to make for very production-ready systems that you have a lot of confidence in. Hopefully that gives you a little bit of a taste. There's more to read through in our docs. You can also subscribe to our mailing list, our YouTube, and join our Slack to ask all the questions that you want. Thank you.